But I guess I better record because otherwise it's hard to catch up. Okay, so we won't do a review, right? But we did finish talking about annuities. So ordinary annuities, I guess I will. So last day, we finished chapter 6. On ordinary annuities. Ordinary annuities. An ordinary, ordinary, ordinary. I don't know what I was doing here. Ordinary, there we go. Annuity. I can't spell at all today. Or maybe it's my writing, I don't know. An ordinary annuity, regardless of if the payment frequency and the compounding frequency are the same, right? An ordinary annuity is when the payments are made at the end of each payment period. So payments are made at the end of each payment period. So what that looks like on our timeline, because today we're going to go to annuities due, and annuities due, the payments are being made at the beginning of each payment period. So for an ordinary annuity, which we were doing last day, right, we've got today, and then let's just say a general period 1, period 2, ... to the n-1 period, and to the nth period, whatever that is. All right, so this is just a general timeline because I want to illustrate the difference, the subtle difference between an ordinary annuity and an annuity due. In an ordinary annuity, the payments are made at the end of each payment period, right? So if we're starting today, there would be no payment today. It would be at the end of this period, right? So our first payment that we were doing last week, or this week too, we put our first payment here at this first tick, right? And then we had payments PMT, 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 PMT. So let's just remember that as we introduce section 7.1. 7.1 is on annuities due. So instead of an ordinary annuity, now we have an annuity due, and we'll do the same thing. So an annuity due is when the payments are made at the beginning of the payment period. The payments are made at the beginning of each payment period. So at the beginning. Payments. Okay. So the only difference is, okay, now instead of waiting until the end of the payment period, now we're going to make a payment right away, right? And so all of these payments here, right, all of these guys are going to get shifted back one, right? Because instead of waiting for, so here's one payment period, right, the first payment period, instead of waiting until the end of that payment period, now to indicate that I've got an annuity due, I shift this payment to today, right? And so all of these get shifted to the beginning, right? And so that means that even this last one is going to get shifted to the beginning, and that means that there is no payment. So the only difference on our timeline is going to be that all these payment amounts get shifted over one tick. And so now we have, so today we've got period 1, period 2, ... to the n-1 period, or period n-1, I guess, and the nth period, period n, if I'm being consistent, but I guess I'm not. Okay. So now these payments start today and go all the way to the beginning of the last payment period. And so the only difference here is that now we've got a payment here and there's no payment here. Besides that, everything stays the same. Everything for annuities stays the same. So what we're going to have, right, is if we have an annuity due like this, right, then we can still calculate a future value, for example, right? But if we imagine adding another tick mark at today -1 period, whatever the period is, and we ended it here, right? Now, this would be back to an ordinary annuity, right? And so what we can do is we can say, well, we can use all our formulas that we developed for an ordinary annuity, except we need to have that little bit of extra interest, right? And so what this is going to look like, right, is these payments are going to funnel into, let's talk about the future value. It's the same for the present value, right? We know what the formula looks like if we have an ordinary annuity, right? We talked about those formulas last day, we used them. And so this future value, if we just end at the n-1 period and ignore that last period, then that's going to be the same as the future value. But this is the future value of an ordinary annuity. So that's not exactly what we want. It's close to what we want, right? But if I'm making payments at the beginning, then, and I'm going to the end of the nth period, right? Then I need to, let's say because it's more pleasant to talk about, right? We need to get interest for this extra period, right? That I've got my money sitting there. And so here, the difference between here, the future value here and the future value here is just times 1 plus I, right? Times the amount of interest that you would make, the periodic interest. And so to get from this future value, an ordinary future value, to a future value, and then we just denote it, as you probably noticed on your formula sheet, we just write a little subscript due, right? And so the future value due, well, the future value due, let's just talk about it. The future value due is the future value So of an ordinary annuity, and then just multiplied by 1 plus I. Right. So, and then I'll just highlight here, plus interest from 1 period. Plus interest from 1 period. So then we have the future value due is going to be the future value times 1 plus I. From your formula sheet, if you have a look, right, there's a lot going on your formula sheet, but it's actually not that different because what we know the formula for just an ordinary future value. And then the only difference between a future value due is having that 1 plus I tacked on to the end. Right? And so if we have a future value, future value due is the future value, the future value times 1 plus I, well, we can replace that future value with just the ordinary future value, which is PMT, and then big square brackets times 1 plus I to the n minus 1 over I. And then don't forget that 1 plus I. Right. Where I is that periodic interest rate, as always. Let's see if I've got the formula sheet somewhere here. Yeah. So we're on the back page, and we're really focusing on these 2 sections for now, right? Those last 2 formulas are perpetuities, and we'll get there at the end of today. And then we'll have talked about every single formula on the formula sheet. Right, and so our future value due, I'll do a pink square around it just to indicate that it's on your formula sheet like I have been doing, right? But I've also got your formula sheet here. We can do little comparisons, right? And just kind of compare and contrast here. So the future value due, the only difference between the future value and the future value due is that times 1 plus I. So this section here is the same as this section here. Same thing if we go on to the present value due behaves the same way, right? We've just got that extra period of interest to deal with. And so this and this, they're the same. If we're going to dissect the rest of it, well, then we can say, okay, well, for N, for an ordinary annuity, we have the future value over the PMT. Looking at everything else, everything seems to stay the same. It's just this little section changed. And the reason for that is, well, here we've got the future value, and here we've got the future value due over 1 plus I. And the reason for that, I want to try to right. So these are the only differences. And it'll be the same for if we know the present value, so I'll just explain it for the future value. We know that the future value due, we said, is an ordinary future value times 1 plus I. So in our first formula on the left-hand side, we've just got the future value. And so what we can do is we can solve for the future value. So the future value due divided by 1 plus I is the future value, right? So if payments are made at the beginning of each payment period, then we've got a future value due or a present value due. So then we need to swap out all our future values with future value due over 1 plus I. Right? Or the present value due over 1 plus I, they behave the same way. Similarly, the present value due is the present value times 1 plus I. So the present value must be the present value due over 1 plus I. Same idea. So there are a lot of formulas. Do you actually need the formulas on the left-hand side? No, probably not. So here, on the left-hand side, you've got ordinary annuities. And on the right-hand side, you've got annuities due. Taking a step back, there's a lot of arrows going on, but hopefully they're pretty explanatory. All right, so now that we know what these formulas look like and why, right, it's just that extra period of interest that we have to pay or that we get depending on the situation. And so let's do an example. Let's do example 224. Payments of $350 are made at the beginning of each month. Okay. So remember on the test that you guys just wrote, test 2, you had to keep track of if you have compound interest or simple interest. So now there's that added step of, okay, well, we're not going to have so much simple interest, especially not on test 3, right? But now we're going to have to check, okay, is our compounding frequency the same as our payment frequency? If not, we have to find I2. And are our payments at the beginning or at the end of the payment period, right? Because that's going to dictate whether you have an ordinary annuity or an annuity due. So now, if payments are made at the beginning of each month, you've got an annuity due. What is the car worth if payments continue for 5 years and money earns 4% per year compounded quarterly? So I'm going to use the same steps that I used before, right, where I highlight what the compounding frequency is and what the payment frequency is. And so I've got my compoundings per year, compounded quarterly, so 4. In terms of my formula, right, that's F1. And my payment frequency at the beginning of each month, so my payment frequency is 12, which is going to be our F2. Since F1 is not equal to F2, I have to find I2. Right? So since F1 is not equal to F2, we need to find I2. Which means we need to find I1 first. I1 is R1 over F1, which is 0.04 divided by quarterly, which is 4, so 0.01. So now we can find I2. I2 is going to be 1 plus I1 to the power of F1 over F2 minus 1 from your formula sheet. That's probably one of those that you'll end up memorizing even if you don't want to, because you use it so much. So if we're finding I2, we've got 1 plus 0.01 to the power of F1, which is 4, over F2, which is 12, so 4 over 12, and then minus 1. Dealing with the brackets first, we've got 1 plus 0.01 to the power of 4 over 12, which I'm going to put in brackets, and then minus 1 is 0.00033222284. I'm going to store this in 1. And remember, as long as you make a note that where you've stored it, you can just write recall 1, recall 2, right? That's fine. Okay, so now we're ready to make our timeline for this. So we start today, right, beginning today. So payments of $350 are made at the beginning of each month toward a car. What's the car worth if payments continue for 5 years? So because I'm making monthly payments for 5 years, right, what I'm going to have is 12 times 5, so 60 payments, so 60 months. That's going to be my main time value, but up above it, I'm just going to write 5 years. But my ticks have to be in terms of payments, right? And so remember, I want to see at least 3 payments at the front and at least 2 at the back. So today, and then 1 month, 2 months, ... to 60 months, which the one before that would be 59 months. So the only way that we can indicate that we have an annuity due versus an ordinary annuity is just shifting those payments over by 1. So we've got first payment today, and that payment was $350. And then we've got $350 payments every month until the beginning of the 60-month period, which we're going to just put under the 59 months. And that's our last payment. So if you've got an ordinary annuity or an annuity due, you need to have your payments on your timeline in the right spot. Otherwise, I take a mark off because it's wrong. Okay. So if we want to know how much this car was worth, that's the value today, right? So we're drawing all these payments back to today. So we're going to funnel all these, show it like this. If you don't like doing curly brackets, that's fine. You can just do something like this. You can use a square bracket if you like, but I think it's pretty fun to do curly brackets, so I'm going to keep them. So this is going to get pulled back, and the value today is a present value, but because we've got an annuity due, I have to put a present value due. Same thing on my arrow. Less important for annuities, right? Because we've usually calculated the number of payments to make up our ticks, but N is time times F2, which is 5 times 12, which we already found was 60. And we already have I2 calculated, so that's ready to go. All right. So now we can find the present value due. So we use the formula. The present value due is the payment amount, and I want to see just the blank formula first. The payment amount times 1 minus 1 plus I to the negative n over I. Up until this point, this is the exact same as the present value that we used before, but then we have to tack on the times 1 plus I. I'm just going to shift this over here because I should have left myself more room. With all those I's, if I'm writing out the numbers, which you don't have to, you can just write recall 1. But I'm going to, just to show you, it's going to take up a lot of space. So our payment amount is 350 times 1 minus 1 plus 0.0033222284 to the power of negative 60, right? Our n is 60, over 0.0003322284. All times 1 plus 0.0033222284. I ran out of room anyways. Or, if you prefer, you may write equals 350 times 1 minus 1 plus recall 1 to the negative 60 over recall 1 times 1 plus recall 1. Assuming that you've said where you've stored I2. Either way, if we do these calculations, right, starting from the inside brackets, right, the small brackets inside the big brackets and blooming out, right, we get 1 plus recall 1 to the power of negative 60 equals 1 minus that guy divided by recall 1. Just so you can check your work, I get 350 times 54.31671541, and then times 1.0033222284. Oops. Man, that's annoying. There. So that times, and then in brackets, right, because I want to do the 1 plus recall 1. So a bracket 1 plus recall 1 end bracket equals, right, so you want to make sure you're not doing any illegal math. So I'll just do a check-in point here. As before, if you just went straight to the answer after showing me what values you're going to be calculating, that's fine, right? So after that step, if you go straight to the answer, that's fine. So this would be 350 times 54.49717094. and then times 350. Finally, we get 19,074.00983. But the value of the car is in money, so we know we have to round to 2 decimal places. And so 19,074.01. Therefore, the value of the car is 19,074.01. Now, let's do this problem on our calculator, right? Just like we did before, because we know what the answer is supposed to be. So now we can make sure that we've got our calculator under control. So we can solve this problem on our calculator. But remember, you have to list all the entries. So we can solve this problem on our calculator. We need to have N, the interest per year, the present value, PMT, and I kind of do have these memorized, but I'm just listing them from left to right from your calculator, right? So that's the order that I want to see. So PMT, future value, and then going into the second menu for the payments per year, the compoundings per year, and beginning or end. N is still the number of payments, right? And so N is 60. The interest per year has to be just the 4%, right? So it just needs a 4. The present value, that's the value that we're trying to solve for. Right? Same idea as for ordinary annuities. The payment amount is 350, but remember, we have to make it negative because it's leaving our hands, right? So we're making these payments, and so these are going to be negative $350 payments. The future value, once we're done making payments, is going to be 0. And then we said that we have 12 payments per year and 4 compoundings per year. And this is where we have to change it to the beginning mode. This is the only thing that's changed, right? So to change to Bgn mode, you're going to hit second and then payment. This is the Bgn menu. And then to change mode, hit second enter. So if we go to second payment, it's telling you it's at the end, right? So if we're going to change it, you have to hit second enter, which is set. Oops, it's weird. All right, so set the mode. And then to exit out, you go second compute, or which is the quit, right? And second quit. So now we're at the beginning mode. Even if we exit out of here, you'll notice that there's a little reminder saying that you're in Bgn mode on your screen, right? So even if you're at 0, it should have a little Bgn up at the top, just to remind you. Okay, so now we're in Bgn mode, so that's good. So now we can just enter these values. So we've got 60 for N, 4 for interest per year, leaving the present value because I'm going to come back and compute it, and 350 negative for my payment, 0 for the future value, and then my payments per year are going to be 12. Remember, in the second menu we have to hit enter to save it, and then the compoundings is 4, enter, and then we can quit. So now we're going to jump in and we're going to compute that present value. So CPT compute present value, and I get 19. Oh, I guess I could use a different color, but 19,074.00983, which is the exact same as we got by hand. Is using the calculator a lot easier? Yeah, it is. Let's see here. All right. So let's do example 227. Susie takes out a loan of $20,000 so that she can purchase a new car. She intends to pay this back with $175 installments at the beginning of each week. One thing about Annuities Due is, unless it explicitly says at the beginning, then it's not going to be an Annuity Due, right? So unless it says at the beginning, starting today, then you can assume it's an ordinary annuity. But if it says beginning or starting today, then you've got an Annuity Due. Assuming the bank charges a rate of interest of 3.5% compounded annually on her loan, how long will it take for her to repay her debt? So instead of calculating a present value or a future value, now we're going to look at calculating N, right, which is how we get to the length of time. So same thing as always, right? I'm going to start by figuring out what my compoundings per year are, compounded annually. So my F1 is 1. And my payments per year are weekly, so 52 is my F2. Since my F1 and F2 are not the same, I have to find I2, which means I have to find I1 first. So I'm going to start by finding I1. You'll notice that I stopped writing since F1 does not equal F2. We have to find I2, right? I'm just assuming that we know that now. So I1 is R1 over F1, which is 0.035 over F1, which is 1. So our I1 is 0.035. Now we can use that to find I2. I2 is 1 plus I1 to the power of F1 over F2, then minus 1. So we've got 1 plus 0.035 to the power of F1, which is 1, over F2, which is 52, and then minus 1. So we've got 1 plus 0.035, then to the power of, oops, wrong button, 1.035 to the power of, and in brackets, 1 divided by 52 equals, that's not right, 1 plus 0.035 to the power of 1 over 52 equals, there, minus 1. I get 0.12, zeros, 1, 2, 3, 6, 6, 1, 7, 8, 5. That's how much interest we make each week. Okay, so now we have our I2, so that's good. So now we can calculate N. We can map this out on a timeline. Let's do that first. Oops. Let's say she started today. We don't know how long she's going to make these payments for, right? So I'll just put a little question mark here, but I know it's going to be N payments or N periods. And I know the one before that is at N minus 1 periods. And after today, I've got the first period, 2 periods, dot, 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 right? Still have 3 ticks in the front and 2 ticks in the back. She's going to make payments starting today, right? Because they're at the beginning of each week, so all these payments are going to get shifted back 1, and they're $175. So starting today, she pays $175, $175, $175. And then that last payment is essentially at the N minus 1 tick. These are all paying off a loan, right? And so loan amounts are present values. If she was saving this and I wanted to figure out how much she would have at the end of this time, right? Or she saved until she had $20,000, that would be a future value, right? But now these guys have to funnel back to $20,000 because that's what she's paying off. And just as a little note, this is a present value due. We don't know what N is, so I'm just going to put N equals question mark on my arrow just for completeness. If I know the present value due, that tells me which formula to use for N. And notice that there's 4 formulas that you could be choosing from, right, for N. So you kind of have to be able to whittle it down, right? So we have a present value. So it's one of those bottom 2. And we have a present value due, so it has to be the bottom right one. So now we know that N is the negative natural log of 1 minus I times present value due over the PMT times 1 plus I, and then divided by the natural log of 1 plus I. I'm trying really hard not to say log for ln, but sometimes I might slip up. Okay, so we know all these values. So we've got the negative log of 1 minus I2, which I'm going to store in 1. I'm always storing in 1. So what I'm going to do is I'm going to cheat and just write recall 1. I'm not going to write out I. 3 times. So I'm just going to write recall 1 times the present value due is the 20,000 divided by the PMT, which is your payment amount, so 175, and then times 1 plus recall 1 is your I. And then that's all divided by the log, the natural log of 1 plus recall 1. All right. So starting inside my brackets, I have to deal with the multiplication and division first. And so I'm going to start by dealing with the 20,000 divided by, and then in brackets, 175 times, and then another bracket, 1 plus recall 1, and bracket equals, I'll just do it all the way through, times recall 1, and then 1 minus that. Here, I'll do a check-in point. You don't have to, you can go straight to the answer if you want, but I get the negative log of 0.924417473. If that's not what you have, you did it wrong. So you have to be careful, right? Over the log of 1, I'll just do 0.000661566, right? Oh, 15. Oh, never mind. Wrong number. 12306611785. You'll see why I mucked up in just a second. Keeping 0.9244 on my screen, I can take the log of that, so ln, and the negative of that puts me at 0.078591499. And then that's divided, and I'm gonna just for safety's sake, store it in 2, because I don't want to have to do that again. Over, so 1 plus recall 1, and then I want to take the log of that, and here's where my eye deceived me. 0.000661566. See how similar those are? It's because we're taking the log of something close to 1, but still. Might as well store this in 3. So now, if I have to calculate this, I can just do recall 2 divided by recall 3, and I get 118.79611759. Remember, for n though, we can't have 0.796 of a payment, right? So we're going to bump that up to 19 payments just for seeing how long it's going to take in weeks. And so we would need n equal to 119 payments. So n, remember, is the time times the frequency, but also remember, so if n is the number of payments, oops, the number of payments, Well, then F must be the payment frequency. The P per Y or F2, whichever you prefer. Right, so just be careful. If N is in payments, then your F has to be the payment frequency. So what we have is we have 119 equals time times the payment frequency, which is 52. Solving for T, we get 119 divided by 52 is 2.28846153 years, because T is always in years. And then usually on the test, I would say round time to 2 decimal places. Right. So T would be approximately 2.29 years. Any questions about that? Oh. So far, so good. So that's annuities due. There's nothing really crazy going on. Let's get into section 7.2. 7.2 is on deferred annuities. So a deferred annuity is when the payments that we're making or that we're getting, right, are deferred, so put off for some amount of time. So, oops. When the payments you are making or you are getting, depending on the situation, are delayed, we have a deferred annuity. Right. Driving here this morning, I heard on the radio, I can't remember, it's some car dealership is advertising that you're not going to make a payment until February 2020, right? And so, yeah, you get to buy this truck or whatever it was, and then you're not going to make a payment. You're not going to start your payments until February 2020. That's a deferred annuity, right? And so, for example, do not pay until February 2020, for example. Woohoo! Don't worry, you're still paying interest, but it won't feel like it. Mm-hmm. So we have all these concepts, so there's no new concept to look at. It's just kind of expanding and combining all the things that we know already, right? So let's have a look at an example and just kind of plug through it. We're going to do example 228. Today is the beginning of January. Okay. Your bank offers you an investment which pays $100 per month for 5 years, beginning in 5 years. So it's not going to start right away. It's going to start 5 years from now, with the first payment at the end of January. So if money earns a rate of return of 3% interest per year compounded bi-weekly, what is the most that you should pay for this investment? Basically, what is the present value of this investment? So as per usual, I'm going to map out, see if I need to find I2 or just I1. And so I'm going to start with my compoundings per year. My compoundings per year is the same for both of these. So biweekly. Well, actually, me trying to be consistent might not be that great in this case. Let's have a map, or let's do the timeline, and you'll see what I mean in a second here, because there's going to be a section of compound interest, right? Just pure compound interest, and then an annuity section. So I'll even erase that for now. So our breaking points were today, and then 5 years later. And then we get payments for 5 years. So that's putting us at 10 years, but I'm going to put that up above because we're getting payments monthly, right? So this distance is 5 years. And so in terms of payments, right, these payments aren't going to start until the 5-year mark. And so we've got 5 years of monthly payments. And so 5 times 12 is 60 months. Right, in terms of payments. And so 5 years in terms of our payments translates to 0 months. So then we're going to get payments every month. So here's 1 month, 2 months, ... up to 59 months, and then 60 months. So now this is where we need to keep our wits about us and say, okay, well, are the payments at the beginning or at the end? Looks like they're at the end of the month, right? Because with the first payment at the end of January. So we're back to an ordinary annuity, and we're getting payments of $100, $100, $100, and $100. We only know how to find the future value of these guys up to this point, right? So we can do that, but then from here to here for 5 years, we've just got compound interest like we were doing on test 2, right? And so what I'll do, even though we've got compound interest for annuities, right, I'll only call this kind of basic compound interest that we were doing a compound interest section. Hopefully that's not too confusing. So these are going to trace back to just an ordinary present value. Right, so some PV. Thinking about, well, how much is this all worth today? That present value is the future value of the value today, right? And so we've got this kind of link here. So we've got our present value 1. That's the first thing that I'm going to calculate. And then I've got my future value 2 is equal to the present value 1, right? But just keeping in mind that it switches from being a present value to a future value in relationship to today. And then this future value is going to get pulled back to some present value, and that's going to be our third calculation. N goes on the arrows, right? And so N on the annuity arrow is the number of payments. So N is time times the frequency, 2, which is going to be 5 years times 12, which is 60. We already decided that. And then on the compound interest, right, for compound interest, N is just the number of compoundings. So we've got N is time times F1, which is also 5 years, but times compounding biweekly 26. Which is 130. Oh. So, all right. We can use our calculator as long as you split up these sections and kind of map out what you want, right? You can use the calculator for the annuity section and then for the compound interest section. But just for completeness, let's just do it by hand. And then you can check your work with your calculator. How about? So we said that the payments, or sorry, I'll start with the compoundings per year, which were 26, compounding biweekly, which is your F1. And then the payments per year were per month, 12, which is your F2. I1 is R1 over F1. One thing to keep in mind is it's possible to have different interest rates for each section, right? So the annuity might have a 3% compounded quarterly, and then the compound interest might have a 4% compounded semi-annually or something like that, right? So you'd have to really keep these things separate. For now, because this is our first deferred annuity, we don't have that, but it is something to keep an eye out for. So I1 is R1 over F1, which is 0.03 divided by 26. 0.03 divided by 26 is 0.0011538846, which of course I'll store in 1. This is going to be the interest that we use for our compound interest section, right? That's when we didn't have to adjust to match the payment frequency, but for the payments, I have to find I2. So I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus, I'll cheat, recall 1 to the power of 26 over 12, then minus 1. To the power of 26 over 12, I get 0.00250163. And I'll store that in 2. which kind of makes sense. I1, I2, store 1, store 2, sold. So now I'm going to start by finding the present value 1, right? Because how these are going to work is I know everything except for the present value here, which I'll need in order to find the next present value. So you'll have to map out, okay, there will be some place where you know everything except one thing. You can solve for that, and then you can just keep going. So present value 1, this is an ordinary annuity, right? And so we can just use the PMT times 1 minus 1 plus I to the negative n over I. The payment amount is $100 times 1 minus 1 plus recall 1. Sorry, recall 2. Haha. To the power of negative 60 over recall 2. Starting inside the little brackets and blooming out, right, we get 1 plus recall 2 to the power of 60 negative. 1 minus that divided by recall 2 times 100, going and not showing any steps because this is probably what you'll end up doing anyways. We showed them earlier, so I'm not too concerned. 5,564.957846. These are dollar amounts, right? And so we're going to round to 2 decimal places as soon as we've got a final dollar amount. And so 5,564.96. We know that present value 1 equals future value 2, so they're both equal to 5,564.96. So now we can use that to solve for, and then there were 3. Hey guys, hey, did you get your test? What's your name? Say that again. Jimmy. Sorry. Yeah. All right. Three people. You guys are awesome. All right. So we know the future value now has to be $5,564.96. And so now we can use that to solve for the present value. And so switching back to our compound interest, right? Now we've got the present value is the future value over 1 plus I to the power of n. A note here is that this guy, I, we're going to use I1 and n is time times F1, right? The number of compoundings. Or we could use I2 if you want to, just remembering that then where n would need to be t times f2, right? It's still just going to be the number of compoundings, whether you're compounding weekly or bi-weekly or whatever we have our options. I can't remember. Oh yeah, monthly or bi-weekly. It actually doesn't matter as long as our n's match our i's. So just to keep them separate, I'm going to use I1. Okay. To keep things separate, I will use I1. So n must be the time times F1, which is 5 years times, and then we said 26 was 130. And I1 is in store 1. Okay. So doing the calculation now isn't so bad. Present value 3 is the future value 2 if we want to get really picky, times over 1 plus I to the power of n. This is going to be 5,564.96 divided by 1 plus recall 1 to the power of 130. Oops, 130. So I'm going to do 1 plus recall 1 to the power of 130. And then I'll do 5,564.96 divided by that previous answer. And I get 4,790.219662, which in money, 4,790.22. Going back to the question, what is the most that you should pay for the investment? The most that I should pay is $4,790.22. Therefore, the most I should pay for this investment is $4,790.22. Any questions about that one? So we definitely could do each of these parts on our calculator, right? It's just a matter of mapping it out is the hardest thing. So now what I'm going to do is I've made a special example that's not in the textbook, but probably because you'll need it on a test some point. So here we go. Let's do, we have to write this one out though. Example. You have decided to invest in your RRSP over the next 15 years. So you have decided to invest in your RRSP over the next 15 years. So far, so good, all right? So you're making contributions for 15 years. In fact, you will make monthly payments starting at the end of this month. Starting at the end of this month. Okay. That's the first part. You plan to retire in 27 years. You plan to retire in 27 years. You want your RRSP to pay out $2,000 at the beginning of each biweekly period for 20 years once you retire. So after retirement, or after you retire, you want your RRSP to pay out $2,000 at the beginning of each biweekly period for 20 years. If your investment earns 6% compounded semi-annually, what are your monthly payments? If your investment earns 6%, earns 6% compounded semi-annually, what are your monthly payments? Okay. So just trying to wrap our heads around this, right? If we've got, okay, so I'm making payments for 15 years. These payment amounts, we don't know what they are. That's what we're going to try to solve for. So for 15 years, and then I'm not going to retire for 27 years, right? So 27 minus 15, it just sits there making interest. And then I start getting these payments, right? So there's going to be payments, compound interest, payments. Right? So to map this out, gonna wish I had a bigger page, but oh well. We'll start today, and for 15 years, and I'm gonna put the 15 years up above, right, because I'm making monthly payments, and so that's more relevant. But for 15 years, and then at some point at the 27-year mark, 27 years, I retire, and then I want my payments to go for another 20 years. So in terms of today, right, that's 47 years from today. Because this distance this distance here is 15 years. Between 27 and 15, 27 minus 15, there's 12 years. And then between 27 and 47, there's 20 years. Okay. So I'm making monthly payments for 15 years. So that means that I'm making 15 years times 12, 180 months worth of payments. Oops. Up to that point. And so I need to make a little mini annuity due timeline here. And so I want to have 1 month, 2 months, up to 179 months. Right. I still want to I still need to have 3 ticks in the front, 2 ticks in the back. In terms of payment amounts, I don't know what they are. So, and we've solved problems like this, right? So we just denote this by the PMT. But we need to make sure that these payments are either at the beginning or at the end. And so you will make monthly payments starting at the end of this month. So if we're starting at the end, then our first PMT is at the 1 month mark, and then PMT, 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 and then finally a PMT. What's going to happen is that that's going to funnel into some future value, right? All these payments are going to add up to some future value 15 years from today, right? And so I can funnel those into a future value. I'm not going to put little subscripts on here to denote the order of my calculations quite yet, because I want to see the full picture. Right? All right, but then after the 15 years, I'm done making payments, but now it's just going to sit there and make compound interest for 12 years. Right? And so now this turns into the present value of this compound interest, which turns into some future value, which, if you're snaking back, right, has to become the present value of these payments that I'm getting when I retire. So now let's figure out what this annuity section looks like. Now we're getting these payments. And so you plan to retire in 27 years. After you retire, you want your RSP to pay out $2,000 at the beginning of each bi-weekly period for 20 years. So at the beginning, so I'll put 0 bi-weeklies here. I get a payment of $2,000, right? So these have all been shifted to the beginning. And then at 1 bi-weekly, 2 bi-weeklies, ... and then how many bi-weeklies in 20 years? 20 times 26 is 520 bi-weeklies. So the second to last one must be 519 bi-weeklies. Squeezing it in there. Each of those has a payment of $2,000. The last one being at the 519 bi-weekly mark. And these are all going to funnel back to this present value. But because this is an annuity due, I'm going to change this to a present value due. Right, just to highlight. Again, this is the situation where we know everything except for the present value due. Right, so we'll start over here on the right-hand side And then we're going to find the present value due, which means we'll know the future value, which means we can trace back to the present value of our payments, which becomes our future value of our payments. And then we'll be able to solve for the payment amount, right? So our first calculation is going to be calculating the present value due, right? I'm just going to highlight the order of my calculations with the subscript, right? So present value due, that's my step one. Easy enough to find future value. I'll call that my second calculation. It's not actually a calculation, just like we saw earlier. But then this can become my present value 3. And actually, this arrow, right, from present value 3 to future value 2 is actually going the other way around, right? It's moving from the future value to the present value in our case. And then finally, we'll know the future value 4, and then we can use that to solve for the PMT. I'm just going to throw some ends on the arrows. N is 520 payments, we decided. And then the only difference here is that we're compounding. So N is time times F1. Our compounding frequency was semi-annually. So for 12 years times 2 is 24. And then N is 180. I'd say the easiest way to do this is to just use your calculator. So what I want to do is I want to show you how to use your calculator for this, and then we can go through and do it by hand, but I think you'll probably end up preferring your calculator for this one. So what I'm going to do is I'm going to just separate my page here and here, right, to separate these 3 phases of different payment styles, I guess. So here, if we're using our calculator, then each of these is going to have an N, an interest per year, a present value, a PMT, a future value, oops. PMT, a future value, the payments per year, the compoundings per year, and beginning or end. And we're going to have these entries for all of these, each section. So we can just take a little bit of time here, map these out. And beginning or end. Nice. So we're going to start by finding the present value of this annuity due. Right, so the first thing I want to highlight is that we should be in Bgn mode. So we just want to double check. And I'm still in Bgn from before, right? So that hasn't changed out, but if you weren't, you'd have to change your mode. And for this first section, we decided was 520 payments. The interest per year is 6% compounded semi-annually across the board. That's not necessarily always the case, right? But in this case, we've got 6% semi-annually. So for our interest per year in all of these, we can put 6, and for our compoundings, sorry, semi-annually, I think, correct? Yeah. So our compoundings are 2, 2, 2. So those are going to be the same across the board. In this right-hand section, which I'm going to call the first section because it's our first set of calculations, even though they're on the far right, we're finding the present value, so I'm going to indicate that with an asterisk. My payment amount is $2,000. Remember that we have to keep in mind whether this is positive or negative. Since I'm getting these payments, right, I'm getting payments of $2,000, it's coming to me, so it's positive. So positive 2,000. Once that's all done though, after the 20 years, the future value of this is going to be 0. And for my payment frequency, it's bi-weekly, so it's 26. All right. So we can go ahead and plug these in. 520 for N, 6 for the interest, 6 for the interest per year. Skipping the present value, we've got $2,000 as our payment amount, 0 for the future value, 26 enter payments per year, 2 compoundings per year enter, and then we're going to compute the present value, and I get negative 610, which I'm just going to write in a different color here, negative 610,648.1281. Negative just means that I would have to pay that in order to get these $2,000, right? And so that negative doesn't necessarily translate into the second section of calculations, right? You'll have to decide if it's money coming to you or what. All right. Moving on to the second section, straight compound interest. So now our N is the number of compoundings, which is 24. Our present value is the one we're solving for, because our future value is going to be the 610,648.13 if we're rounding properly, which we are. So we're solving for the present value. Our payment amount for compound interest, remember we just set it to 0. There are no payments here. So there's 0 payments. And the future value is going to be, well, one has to be positive, one has to be negative. So if we imagine that, I guess I'll keep my present value positive and keep my future value negative, right? Because it's leaving my hands. So I've got negative 610,648.13, right? Rounding properly. I'm just going to highlight here and here. Those are from the same value. My payments per year, remember for compound interest using our calculator, our payments per year, we just make it match the compoundings per year. And so it has to be 2, and I'm going to change it to the end mode, although because there are no payments, I'm pretty sure it doesn't matter, but just to be safe, I'm going to change the mode to the end mode. And now I can do my calculations. So N is 24. 6 for the interest per year, 0 for the payment amount, 610,648.13 negative for our future value. 2, enter payments per year. Compoundings per year should be 2 already. And compute our present value. The present value I get must be 300,398.4162. Looking at our roadmap here, that's the future value of these unknown payment amounts, right? And so before I forget, I'm going to put that as my future value. So leaving room for a negative in case I need it. But just before I lose this, 0.42 cents rounding properly. And this guy and this guy, they're the same. So now I know what this value is, which means I know what this value is. So now all I need to do is find the PMT. So I'm solving for the unknown payment amount. Oops. So I put a little asterisk there. And I know that my N is 180. My present value is going to be 0, right? Because I start with 0 money. There's no mention of, oh, you have 25,000 already. Oh, 0. We're solving for our payment amount. Our payments per year, we're working monthly, and so our payments per year here is 12. And these were at the end of each month. So we're in this end mode still. Okay. Here we go again. 180 for N, 6 for the interest per year. We wouldn't actually have to change the interest per year because it'll just be 6 until we tell it otherwise, but I don't know, I like to just do it properly. 0 for our present value. Coming back to calculate the PMT, 300,398.42. And is this going to be negative or positive? Well, we can think of it this way. If I'm making payments, those payments are going to be negative, right? They're leaving me. And so the payments are going to be negative. And then the idea is once I'm done, that future value comes to me, right? And so I'm going to make that positive. So I'm just going to leave it as positive for the future value. And we've got 12 payments per year, enter, and 2 compoundings per year, enter. Compute PMT, dun, 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 dun. I get negative 1,039.440387. And the question was, what are your monthly payments Therefore, my monthly payments must be $1,039.44. You can go ahead and do these calculations by hand, right? You just want to keep your wits about you because now you know what your answer should come out to at each step. But we're not going to do that today. You guys have suffered enough. I'm going to save perpetuities because they're just this little fun thing for next day and let you guys go home. How about that? Any questions?
Are we always going to be calculating backwards?
Often, yeah. Yeah, usually it's going to be, you know, like how long were you making payments for or something over here. But yeah, so you use that information and it just kind of flows backwards. Yeah. Any other questions? See you guys next week. I guess it's Thursday already. Crazy. Bye, guys. I guess it's just Alyssa left. See you, Alyssa.